Okay, let's give you guys some more practice. So somehow integrate this. So press pause and have a go. Okay, so to do this, break this up into two fractions. So you've got one fraction here and then another fraction here. So break this up into two separate fractions. So that becomes this. So now it's a matter of integrating this and this. This thing here is easy to integrate because if you look at this here, hang on, this thing here is almost the exact derivative of the second bubble. So if you make this adjustment, here, hang on, 2 and then times a half, and then take this half here is a constant, so take it out here, so it will then become a half, and then now you've got 2x. Now this is the exact derivative of this bottom bubble. So you know when you integrate it, it's going to be a half natural log of the absolute value of the bottom bubble, and then squared here. But then this x squared is always positive, so we don't really need the absolute value. So this thing here will then become a half natural log. We can use brackets now because we don't need the absolute value there. So it then becomes this. So when you integrate this, it becomes this. But let's leave this for the time being. We can integrate this quite easily. This thing here, how would you go about integrating this? You see, if you are really looking for something in such a way that when you differentiate it, it gives you this thing here. This is very similar to well, if you differentiate inverse tan of x, it will give you something very similar. So let's try this. Let's try and differentiate inverse tan of a constant in front of the x. Okay, so if you do so remember we are trying to integrate this. We are really looking for something in such a way that when you differentiate it, it will give you this thing here. If we consider, let's consider this. Let's try and differentiate this. But remember, the only difference is that we've got a k here. If you differentiate it, so we've done this many times. Use implicit differentiation. So blah blah blah. It would then take you to dy by dx equals this thing here. But then we need to translate this cos y. So we would then go back to here, and then create a triangle in such a way that this statement is true. Well, create your triangle in such a way that this statement is true. Well, if this here is y, so when you tan y, tan would be this, and then create this create your triangle in such a way that this statement is true. Well, if you make this to be k over x and this to be 1, then this statement would be true. Well, anyway, differentiate it. Dy by dx would be this, but then you would need to translate this bit here. So create your triangle. So if you make this to be kx, this to be 1, then the hypotenuse will have no choice but to be this. So if you want to translate cos of y, well, cos of y is really this thing here. So therefore, cos squared would be this thing here. So the point I'm trying to make is that when you differentiate, so overall dy by dx gives you this here. The point I'm trying to make here is that when you differentiate this thing here with a k here, it will then give you this. But this is not quite the same as this. You see, if you look at this here, we are trying to integrate this. So we are looking for something in such a way that when you differentiate it, it will then give you this. But making this to be your initial guess, is still no good, because when you differentiate this, it gives you something very similar, but not exactly the same as this. This is very similar to this, but it's not exactly the same. So instead of trying to differentiate kx, let's try and differentiate x over k. Now, if you differentiate x over k, it will give you this. So it's blah blah. Use implicit differentiation. We've done this many times. So dx dy by dx equals this thing here. Then you would still need to translate this. So you would then go back to here, create your triangle in such a way that this statement is true. You see, if you make this to be your triangle, angle y, tan is this thing here, and then you need to create your triangle in such a way that this is true. Well, make the tan is this thing here. So make this to be x, this to be k. So this is your triangle. So once you've got your triangle xk, then the hypotenuse must be this. So cos of y would be k over root blah blah blah. So cos of y equals k over root blah blah blah. So cos squared will be this thing here. So therefore, hang on. So dy by dx equals this thing here. Okay, because hang on, cos squared equals this thing here. Earlier we said dy by dx equals this thing times cos squared. We've just worked out cos squared, so now we need to times it by 1 over k. So blah blah blah. Dy by dx really is this thing here. You might have to pause the video and think it through. But dy by dx equals this thing here. The point I'm trying to make here is that when you differentiate, we are trying to integrate this. So we are really looking for something such a way that when you differentiate it, it will give you this. Now, if you make this to be your initial guess, if you differentiate this, it will give you this thing here. Now, this thing here is very similar to this. We're almost there, because you see, if you factor, so if you change this to be an a here, if you differentiate this, it will be a, and then you've got a squared here. So this matches up with this. This almost matches up with this. So when you differentiate this, it will give you something very similar to this. But the thing is, you only need one a here. You've got one k here. You've got a squared here. So break this up as a times a. Because a is a constant, we can actually move it out here. So it becomes this. So rewrite it as rewrite this as this. So now this is pretty much exactly the same as this now. So when you integrate this, it will be inverse tan of x over a. Okay, so hang on. So visualize this as this. So now when you integrate this, forget about this bit for the time being. Concentrate on this. Well, when you integrate this, so hang on, bear with me. So we are trying to integrate this, but rewrite this as this. Rewrite this as this, and then we can take it out here. So that's this a here, this a here. So now we can integrate this. Integrate this. It should be inverse tan. So when you integrate this, it will give you this thing here. So this a is on the outside, this a here is on the outside. So when you integrate this, it will give you this, and then your final answer will be this. So I've been slowly changing this to this, by the way. Well, anyway, your overall answer would be this. So let me just scroll back so that you can see what's going on here. So this bit here, integrate it, and it's well, we'll work it through for yourself, okay? But overall, the answer is this.